this topic. So let's start the numerical of this topic. So start करते हैं अपने numericals on three-phase circuits. So first numerical for the AC circuit, three-phase circuit is the line A to neutral, the line A to neutral voltage is 10 angle 15 degree volt. ठीक है यहाँ तक. For a balanced three phase star connected load with phase sequence ABC, okay, with phase sequence ABC. ठीक है भाई यहाँ तक. Now voltage of line, the voltage of line B with respect to line C is given by now option A. पहला ऑप्शन जो है हमारा 10√3 एंगल 105 डिग्री. बी ऑप्शन जो है हमारा है 10 एंगल 105 डिग्री और सी ऑप्शन जो है हमारा 10√3 -75 डिग्री एंड द लास्ट ऑप्शन इज -10√3 एंगल 90 डिग्री. ये रहे हमारे ऑप्शन. ठीक है यहां तक. सो देखते हैं क्या इसका आंसर होता है ना. सो एक बार रीड कर लेते हैं क्वेश्चन. द लाइन ए टू न्यूट्रल वोल्टेज, दैट इज इन द क्वेश्चन दे हैव गिवन VAN, that is what how much it is 10 angle 15 degree. Okay, so they're asking to find BBC. Okay, so we have to find. Now first thing that is in your mind, in star connection line voltage is √3 times of phase voltage. So in that option there is √3, that will be correct. Okay, so your B option is wrong. Okay, B option is wrong, but let's find how to calculate this voltage. Okay, so in the given question, phase sequence is ABC. Phase sequence is ABC. Okay, so let's find the phase voltage phasor diagram. So it is VAN. Okay, and it is at what? It is 10 angle 15 degree. Okay, now. So the next is BVN, and this should be of BCN. Okay, so let's take the values. Now if you see this is at 15 degree, then this should be of, if it is of 15 degree, then the phase angle between each and every one should be of 120 degree. Okay, it is of 120 degree. So if it is a 0, then it is -20. Okay, then 0 minus 120, that is -120 degree. Now to have a 120 degree phase shift, it is 15 minus x, then it is of -120, then it is 15 now. So it is 15 plus 120, it is x. So it should be of 135. Okay, so it is of 135 degree minus. Okay, and let's check 135 minus 15. Okay, so just wait, let's first draw the question, then we will find the answer. Okay, so it is your minus VAN, it is of minus VCN, and it is your what? Minus VVEN. Okay, VVN. ठीक है यहाँ पे. And they are asking to find what? BBC. Okay, this voltage. Okay, so let's draw this thing. This voltage they are asking. Okay, so let's see the answer. So if you have your previous history, VAN is equals to V angle 0 degree and VVN is equals to V angle minus 120 degree. So the phase difference between these two is 0 minus 120, that is 120. Okay, then we have to create the phase difference of these two should be of 120. Okay, then how we can put? Okay, so 15 minus, it is minus 120. Okay, just wait, it is 15 and minus x equals to 120, and it is 15 plus x equals to 120. Then x is 120 minus 15, it is what? It is a 105 degree. So it is at this VVN is 105, sorry, it is 10 angle minus 105 degree. Okay, similarly if you see the difference of these two, okay, so 15 is 0 minus 120. Okay, if you have the VVAC and VCN is equals to V angle plus 120 degree. Now if you will take these two, then it is 0 minus 120, so it is minus 120. Okay, so just create to 120 degree. So I just 120, okay, minus 120 I have to create. So it is at 15, and if I put as 130 minus 135 minus 15, so it is 120. So I just put here at 10 angle 135 degree. So let's check again. First, this is 120, 135 minus 15 is okay, na? 135 minus 15, 120 degree. And let's check also, this is at 15 and this is at how much? 105. So just let's check, 15 minus 105 equals to what? So 15 plus 105, it is 120. So each and every phase voltage are at 120 degree. Okay, so this is about the diagram. Now they are asking to find the voltage between these two. Okay, so if you see this angle is 60 degree. Okay, this angle is 60, then this angle is also 60 degree. Okay, this angle is 60, then this angle is 30 and this angle is also 30 degree. Okay, now this VB, that is VBC is equals to root 3 BP. So we have to take root 3 into 10 and we have to see the angle. Okay, so let's see the angle. It is at what? 15 degree. Okay, it is at 15, then it should be of 60 now. So it is of 60, so it is 75 degree, minus 75 degree. Okay, so we have to take the VBC is equals to root 3 10 into 10 angle minus 75 degree. So this is 75. So what are the option? So I think this option C is correct. This option C is correct. Let's take next question for the three-phase circuit. So next question देखते हैं अपना for the three phase circuits के लिए क्या है. So हमारा next question है three phase circuit के लिए. Two resistor are equal, a three phase delta connected load. A three phase delta connected load. What is that question? Okay. Let's see the question. Where the question goes out. Yeah, this is the question. A three phase delta connected symmetrical load symmetrical load consume P watt of power from a balanced supply from a balanced supply. Okay, then if the same load if the same load is to connected in star to the same supply then what is the power consumption? Then what is the power consumption? And what is the power consumption? Okay, so let's see the option. So first option जो है आपका P/3 and the next option is P. C option is your √3P and the last option is 3P. So let's see the answer of this question. Okay, so if you see this your theory or your lecture notes or your video lecture, whatever you are reading, then if a load is connected in delta, if a load is in star, then it is consuming P watt, then the load in delta is consuming 3P watt. Okay, so P delta is equals to 3P star. This is the formula that I have given to you. Okay, so in delta the load is consuming P watt, and if the same load is connected into the star, then what is the power? Okay, so in delta it is P. Then 3 into P star. So P star is equals to P/3. So option number A is correct for this question. The option number A is correct. Let's see the next question. So देखते हैं अपना next question. So ये तो दो क्वेश्चन हो चुके हैं. देखते हैं अपना नेक्स्ट क्वेश्चन फॉर द 3-phase circuits. Next question is about for a balanced star for a balanced star connected three-phase circuit shown in figure. The line to line voltage is 208 volt RMS. Okay, and the total power consumed by the load is 432 watt. Okay, now at a power factor of 0.5 0.6 leading. 0.6 leading. Okay. The approximate value. The approximate value. The approximate value of the impedance. The approximate value of the impedance Z is okay. First option देख लेते हैं क्या, then diagram. 33 angle minus 53.1 degree. Okay. And the next option is 60 angle 53.1 degree. C option जो है हमारा 60 angle minus 53.1, and the last option is 180 angle minus 53.1. Okay, so this is the option, and we have also the diagram for the load and source. This is your diagram that is given in your question. So it is an VAN, VVN and VCN. Okay, and we have also a star connected load. Okay, so let's connect the star connected load, and we have also three phase load that is in same phase sequence. So this is A, this is A. Okay, this is B, so this is B. So just connect like that, and this is your C to C. Okay, so this is capital C and this is small c. Okay, and it is marked as Z. This is capital N. And anything else on the diagram? Yes, 400 volt phase, 400 volt phase valence source T. Just it is not. Okay, and nothing on the diagram. Okay, so let's see the solution of that thing. Okay, now, so if you read the question properly, then what I need to have the impedance. Okay, so Z is equals to V upon I need this thing. Okay, so if you want to calculate this thing, then first we have the voltage. Where is the voltage? It is 280 line to line RMS. Okay, so in a star connection, VL is equals to root 3 VP. Okay, so VP is what? VL upon root 3. So it is what? 208 upon root 3. So this is your voltage, and it is at angle 0 degree because it is the reference phase voltage. Now similarly for the three phase system, PL is equals to root 3 VL IL cos phi, and for the star connection, IL is equals to IP. Okay, so first we find the IL, then 432. Okay, it is the 432 divided by root 3, and how much is the voltage? That is, I think 208. Okay, so just into cos phi is also given to you is 0.6. Okay, so just take the value of Z. Okay, just take this value of Z only. So Z is what? It is 208 upon root 3. Okay, then it is root 3, then it is 208, and it is 0.6. ठीक है यहाँ तक. So 20 से 208 cancel out हो गया, और I think one we have left. IL is what? Wait, this is wrong. First we put the V0, V0, then it is root 3. Okay, then you have to put I, and I is what? 432 upon root 3 into 208 into 0.6. Okay, okay na? And it is root 3 divided by root 3 na? And 208 into 0.6. Okay, now so solve this. So 208 upon root 3, and it is just above the root 3 into 208 into 0.6. It is 0.6. So 0.6, okay, and it is 432. Okay, so let's see it's cancel out, and it comes out to be 60. Okay, 60. If you calculate this, then it comes out to be 60. Now one thing is remaining. What is the angle? Okay, so if you see, the power factor is leading. Power factor is leading, and power factor is leading. Then, if you remember your theory, I just write here. Now, it is R minus JXC. Then, if you see, the load impedance is like that. So, for the leading power factor, your impedance angle should be minus, and you have calculated the angle. You have calculated the impedance magnitude. So, Z is equals to 60 minus something. It is minus angle. So, ठीक है यहाँ तक. So let's check your option. 33 is wrong just because of magnitude. This is wrong because of magnitude. Okay. And in the B option, the angle is positive. Angle is positive. That side is wrong. So only the remaining option is what? C. So for this question, we have the C option. Okay. Now let's find the next question. So our next question is, so start करते हैं अपने last question for three phase circuits. So हमारा last question है for a balanced three phase supply system. The phasor sum of the line current is not zero. It is not zero. ठीक है यहाँ तक. If the load is okay. So देखते हैं क्या हुआ ऑप्शन. So पहला ऑप्शन जो है हमारा है बैलेंस डेल्टा कनेक्टेड लोड. बैलेंस्ड डेल्टा कनेक्टेड लोड. ठीक है यहाँ पर. और अगला जो ऑप्शन है हमारा वो है अनबैलेंस्ड डेल्टा कनेक्टेड लोड. अनबैलेंस्ड डेल्टा कनेक्टेड लोड. और सी ऑप्शन जो है हमारा बैलेंस्ड स्टार कनेक्टेड लोड. बैलेंस्ड स्टार कनेक्टेड लोड. ठीक है. और लास्ट ऑप्शन है अनबैलेंस्ड स्टार कनेक्टेड लोड. अनबैलेंस्ड स्टार कनेक्टेड लोड. ठीक है यहां तक. सो देखते हैं इस क्वेश्चन का क्या आंसर होगा. नाउ फर्स्ट थिंग, योर phasor sum of then load is okay. So phasor sum of line current is not zero. ठीक है. So बात करते हैं हम इसके सॉल्यूशन की. फर्स्ट थिंग, अगर हमारे पास लोड दो तरीके के ही हैं. अगर हम लोड की बात करें तो लोड एक तो होगा स्टार या होगा हमारा डेल्टा. ठीक है. बट इन डेल्टा कनेक्शन there is no neutral current. There is no neutral. ठीक है यहाँ तक. There is no neutral. So according to option here, in A is delta and in V is delta. So B and A's are wrong. Okay. So in delta connection there is no neutral point. Okay. Now star. In star we have neutral. Neutral is available. Okay. Now, if there are two more conditions, balanced condition and unbalanced condition. Okay. Balanced and unbalanced condition. ठीक है यहाँ तक बात समझ आ रही है. तो न्यूट्रल तो डेल्टा में होता ही नहीं है, तो वहां तो ऑप्शन में ही नहीं होगा. अब अगर स्टार में लोड बैलेंस्ड है, देन IN इज इक्वल्स टू 0. दिस इंप्लाइज दैट IA प्लस IB प्लस IC इज 0 बिकॉज IN इक्वल्स टू माइनस ऑफ IA प्लस IB प्लस IC. ठीक है यहाँ तक। सो अगर स्टार कनेक्टेड लोड है और बैलेंस है, देन न्यूट्रल करंट इज जीरो बिकॉज द फेजर सम ऑफ करंट इज जीरो, बिकॉज इफ यू नो द प्रॉपर्टी ऑफ बैलेंस सप्लाई, द बैलेंस सप्लाई is said to be balanced, then if their phasor sum is zero. Now if the load is unbalanced, then your neutral current is not zero. So this is the mandatory condition for balancing and unbalancing. If load is unbalanced, neutral current is not zero. If load is balanced, then neutral current is zero. Now if neutral current is zero, then VAN, that is Zn into IN, is zero. Okay, if neutral current is not zero, then VAN is not equals to zero. ठीक है, so this is about the neutral current. Okay, and one more thing, neutral current is not depend upon the phase sequence. Your neutral current is independent of phase current. ठीक है यहाँ तक। सो चेक करते हैं हमारा कौन सा ऑप्शन सही है। सो फॉर अनबैलेंस्ड स्टार कनेक्टेड लोड, दिस न्यूट्रल करंट इज नॉट जीरो। ओके, एंड न्यूट्रल करंट इज नॉट जीरो, देन दैट मींस व्हाट, IA plus IB plus IC, the phasor sum of current is not zero, but your current is new. If your neutral current is zero, this implies that the phasor sum of all the current is zero. So which option you should opt? It is balanced. Yeah? So for balance, the phasor sum should be zero. That is wrong. So for unbalanced load, your phasor sum of line current is not zero. That means there is neutral current in the path. Okay, so this is about the three-phase circuit. Now we will start our next chapter. That is the magnetic circuit. So it is about how we can relate your basic electrical to the machine and power system, और जितने भी इसके कॉन्सेप्ट हैं मैग्नेटिक सर्किट के, ये आपके फुल्ली एप्लीकेबल होंगे आपकी मशीन्स में, क्योंकि विदाउट मैग्नेटिक सर्किट आपको मशीन पावर सिस्टम समझने में थोड़ी सी परेशानी आएगी। इवन इन मेजरमेंट ऑल्सो आपको कुछ प्रॉब्लम आएंगी। सो इन सारी प्रॉब्लमों को दूर करने के लिए आपको पढ़ना क्या पड़ेगा, मैग्नेटिक सर्किट। सो हम मैग्नेटिक सर्किट को स्टार्ट करते हैं, और मैग्नेटिक सर्किट में सबसे पहले हम देखेंगे एनालॉजी बिटवीन द इलेक्ट्रिक एंड मैग्नेटिक सर्किट। सो हमने भी थ्री फेज सर्किट में देखा कि किस लोड के लिए हमारी न्यूट्रल करंट जीरो होती है। सो न्यूट्रल करंट जीरो होने का मतलब ये है कि अब आपका लोड बैलेंस्ड है, ठीक है, और लोड बैलेंस का मतलब है आपकी लाइन करंट जो है उनका फेजर सम क्या होगा, जीरो के बराबर होगा। अगर किसी भी सर्किट में जो तीनों लाइन करंट है उनका फेजर सम जीरो है, दैट मींस वो सर्किट बैलेंस है, और अगर सर्किट बैलेंस है तो वहां पर न्यूट्रल करंट क्या होगी, जीरो होगी। ठीक है, अब अगर न्यूट्रल पॉइंट की बात करें तो जो न्यूट्रल पॉइंट है वो डेल्टा में तो अवेलेबल होगा नहीं, क्योंकि जो डेल्टा कनेक्शन है वहां न्यूट्रल अवेलेबल नहीं होता। इसीलिए जो डेल्टा कनेक्शन हमारा वो सेकेंडरी डिस्ट्रीब्यूशन सिस्टम जो कहते हैं होम कंज्यूमर, वहां यूज नहीं होता है। और स्टार कनेक्शन में हमारा न्यूट्रल पॉइंट अवेलेबल होता है। तो जो हमारा स्टार कनेक्शन है वही हमारा जो है थ्री फेज फोर वायर सिस्टम प्रोवाइड कराता है। तो जो थ्री फेज फोर वायर सिस्टम अगर हमें चाहिए तो हमें स्टार कनेक्शन यूज करना पड़ेगा विद न्यूट्रल। तो जो हमारा सेकेंडरी डिस्ट्रीब्यूशन सिस्टम है, जहां कंज्यूमर हम लोग जहां रहते हैं, तो वहां के अगर ट्रांसफार्मर की कनेक्शन की बात करें तो वहां आपने देखा होगा इनपुट पर 3 वायर आते हैं बट आउटपुट पे 4 वायर आते हैं। तो वहां पर जो हमारा ट्रांसफार्मर है उसका जो कनेक्शन होगा वो होगा थ्री फेज, इनपुट पे 3 फेज 3 वायर, और जो आउटपुट होगा उस पे होगा 3 फेज 4 वायर। तो उसका जो कनेक्शन होगा डेल्टा एंड स्टार विद न्यूट्रल। यहां तक ठीक है ना बात? तो ठीक है।